Hello students, I am explaining chapter 2 is matter around the sphere for class 9 science, and in this video I am solving NCERT exercise which is present on page number 22. So here I am going to solve the questions from question number 9 onwards. Before this, whatever questions are there from question number 1 to question number 8, all I have solved in two separate videos, that is exercise NCERT exercise part 1 and NCERT exercise part 2. And this remaining question I am going to solve as a part 3 video. So let's start with question number 9. So question number 9 is, which of the following will show Tyndall effect? So remember, here the question is, they have given some of the solutions like salt solution, milk, copper sulfate solution and starch solution. Out of these all four, which will show Tyndall effect? Before solving, we will see what is Tyndall effect. The Tyndall effect is the scattering of light by colloidal particles. So it is shown by colloids, not true solution. So what is Tyndall effect? It is nothing but scattering of light. And to scatter the light, we require the particle size of a proper size of particles. So total we have three solutions. One is we have true solution, then we have colloid, and we have suspension. So in this, if you see, true solutions particles will be very small, and it is a homogeneous mixture. In colloids, particles will be, just I'll write here small, so they will be little bit of big compared to true solution. But in suspension, particles will be large in size compared to true solutions as well as colloid. So remember, the particles which are present in colloid will have the size in between true solutions and suspension. They should not have very small size and they should not have very large size. Then only these particles can scatter the light. So what do you mean by scattering? Scattering is nothing but if this is a colloidal solution and if these are the particles present in this colloidal solution. If we keep a torch here and if we on it, the light will pass from the atmosphere, and once it enter into the glass, these particles will absorb the light and scatter it like this, you can see. Then this particle will absorb the light and again it will scatter. Then this will attract the light and scatter, and same thing will repeat in this with the all particles present in this beaker. And that's why here in the beaker we can see the light path. The light path is visible in the beaker and also it is visible outside the beaker. This is just due to the size of the particles. Remember, the size of the particles should be in between a true solution and suspension. It should not be very small like true solution. It should not be very big like suspension. Now see here, first is the salt solution. If we see salt solution, it comes under true solution. The size of the particle is very small and it is homogeneous, it is uniformly distributed, and therefore these particles cannot scatter the light. So no Tyndall effect. Second one is milk. In milk, it is a colloidal solution, that is emulsion. Particle size will be little bigger than true solution. They are able to scatter the light, that's why they will show Tyndall effect. Next comes copper sulfate solution. It is also a true solution. All the copper sulfate salt will dissolve in the water and forms a clear uniform composition solution. The particles will be very small. They will not scatter the light. Therefore, we cannot see Tyndall effect. The next is starch solution. Starch solution is a colloid. The particles are bigger than true solution. That's why they can scatter and we can see Tyndall effect. So Tyndall effect can be observed in milk and starch solution because these both are colloids. But salt solution and copper sulfate solution both are true solutions. That's why they will not show Tyndall effect. So this is the answer for question number 9. Now we will move to the next question. Next is question number 10. Classify the following into elements, compounds and mixtures. So here we have some of the example substances like sodium, soil, sugar solution, silver, calcium carbonate, that is CaCO3. Then it is a tin, that is SN, silicon is Si, coal is C, air, soap, methane, that is CH4, carbon dioxide is CO2, blood, it is a mixture of all the components. So these all things which are given and we have to differentiate this, classify these all into elements, compounds and mixture. So first we will see what is element, compound and mixture. So see here, what is element? Made up of only one kind of atom. So you have to be very careful. Understand the basic things. Element is made up of one kind of compound, one kind of atom. What is compound? It is a chemically combined elements in a fixed ratio. So in compounds we will mix more number of elements. Remember, so element means one kind of atom and compound means one or more number of elements. Then the next is mixture. It is physical combination of substances. Mixture can be heterogeneous or can be homogeneous. So here just we are mixing 2 to 3 components or substances with each other. So we will differentiate now. So in elements, we can write sodium. Sodium is the first one, that is Na. So we can write Na, that is sodium here. It is an element. It is consists of only one kind of atom, that is sodium. Silver also we can write here because silver is Ag. In silver, there will be only Ag atoms. In tin, there will be only Sn atom, and in silicon, there will be only Si atoms. No other atoms will be mixed in this. So these all comes under element. Next comes compounds. In compounds, we are going to mix 2 or more elements. So see here, here we can take calcium carbonate. Formula is CaCO3. Calcium carbonate is prepared by mixing calcium element, carbon element, and oxygen element. So 3 elements are mixed. In methane, 2 elements are mixed. One is carbon, one is hydrogen. In carbon dioxide also two. One is carbon, one is oxygen. So when 2 or more elements are mixed, it will come under compound. Mixture. In mixture, we can write soil because soil it is a mixture of clay, then sand, then stone, etc. So it is a mixture and it is heterogeneous. Sugar solution, it is also a mixture. It is a mixture of what? Sugar plus water, and it comes under homogeneous. Then comes coal. Coal also consists of all the impurities mixed in this because coal, this is the one which we are getting in the nature. So it is not a pure one. Then comes air. Air also consists of all the gases, hydrogen, oxygen, nitrogen, etc. So it is air. If you specify some single gas like oxygen gas, then it comes under element. But if you say air, it is a mixture of all the gases, and that's why it is coming under mixture. But it is a homogeneous. All the gases will mix and forms a uniform composition. Then comes soap. Generally, a soap mixture of salts of fatty acids and additives. So when we prepare soap, we are going to mix salts of fatty acid, some bases, some coloring agent, some flavoring agent, etc. So these all additives or addition elements will be added. That's right, it's a mixture. And next is blood. Blood also a mixture because in blood also we can see hemoglobin, we can see plasma, we can see RBC, WBC, etc. So all are mixed in the blood, and that's why this is also coming under mixture. So here we have classified all the given things into elements, compounds, and mixture. After this, we'll move to the next question. Now the next is question number 11. Which of the following are chemical changes? So we have studied the chapter. I have explained whole chapter. You can go through the videos or watch my all the videos. Try to understand every concept and then come to this video so that you will understand what I'm explaining. There are 2 types of changes. One is called physical change and one is called chemical change. So if you are changing its chemical composition, then it is coming under chemical change. And if you're not changing any composition, if you're not changing any its molecular formula or the chemical components, then it is coming under physical change. Like for example, if you ask cut paper into 2 pieces, cut paper into 2 pieces, that is coming under physical change. We are just cutting whole paper from the center and converting into 2 pieces of paper. Here we are not changing in the composition of this paper, but the chemical change means burn paper. If you burn paper, we are going to get ash. We are going to get black ash. When we get black ash, you have changed its chemical composition by burning, by reacting with air, that is oxygen gas. So these are the examples of physical and chemical changes. If you see my earlier video, you'll understand. So now by using this basic knowledge, we will classify the given examples. First one is growth of a plant. So we can see here the answer. In the answer I have written here, chemical change produce a new substance with different properties. So by using this sentence, we have to identify. So see, growth of a plant, chemical change, new substances formed through biological processes. So when we sow a seed in the land, this seed will grow and show some chemical changes in itself. That's why this seed will convert into radical and plumule. So plumule will go up, radical will go down, and this radical convert into roots, and plumule will get converted into shoot or the stem. But when the plant is growing, inside the plant, many chemical reactions are going on. Many new substances it is forming through biological process that is called growth, and that's why this is coming under chemical change. Then the next one is rusting of iron. Rusting of iron means what? When iron combines with water vapors, water in gaseous state, it gives iron oxide, Fe2O3. So see here, earlier it was iron, and after rusting it become iron oxide. So new substance is formed. That's why this is also coming under chemical change. Next is mixing of iron fillings with sand. So iron fillings we are going to mix with the sand. These iron fillings we are not going to react with the sand, just we are mixing them together. We can easily separate them by physical methods by using some magnetic separation method. That's why This is coming under physical change. Next is cooking of food. Cooking of food, it is a chemical change, because you have seen rice will be very hard at the starting. We will put water in this and we will cook. When you cook, this rice will react with the water and the gases and it becomes soft. So it is forming a new substance. That's why it is coming under chemical change. Next is digestion of food. This is also, of course, a chemical change, because when we have food, that food will go into the stomach and food will be broken down into simpler substances and it forms energy. So it is a chemical change. Next is freezing of water. So water means what? It consists of H2O. It is a liquid state. When you freeze, this liquid just becomes a solid. In solid and in liquid, molecular formula will remain same, that is H2O. The formula is not going to change. Chemical composition is not going to change. Only we are changing its state. That is, from liquid, it will become solid. So it is coming under physical change. And the last one is burning of a candle. Burning, whenever we say burning, the reaction is with the oxygen. When candle is burned, this candle wax, candle is made up of wax. This wax combines with oxygen and it forms a new substance. So you can see here, combustion produces new substances like CO2 and water vapor through melting of wax. So this formation of new substance, it is called chemical change, but melting of a wax is called physical. So this also comes under, but the question is about chemical change, and burning of candle will show both the effect, that is both the changes, chemical as well as physical. So we are considering this also in the answer. So these are the answers for this question, that is question number 11. So I hope these all the answers will help you to prepare for your test, class test and exams, even to answer the questions which your teacher will be asking in your classroom. So make a note of these all the answers in your book so that it will help you to prepare for your exam. And if you are getting little bit also help from these all the videos, from these all the slides, then please share my videos with your friends and please consider subscribing my channel. And if you have any doubts in this chapter or in this chemistry topics, then comment those doubts in the videos. Thank you so much.